next speaker will be delivering the next talk on behalf of Dr. Yanzhu Chang. Her name is Aihua Ji. She's a master's student for Dr. Yanzhu Chang. So here you go. You have 20 minutes.
Okay, thank you. Good afternoon, everyone. For personal reasons, my teacher couldn't come, so I stand here to represent him to give you the speech. Now today my topic is the processing mechanism of traditional Chinese medicine, Radix polygoni multiflori based on pharmacokinetic study in vivo. Now first I want to introduce the background. Traditional Chinese medicine and their prescriptions have been widely used by billions of people around the world for thousands of years. In TCM, the processing of Chinese herbs named as Paozhi, which was taken according to the theory of TCM, is regarded as a kind of pharmacy technology. In order to meet the therapeutical requirements to ensure safety of Chinese medicine, enhance effectiveness, and produce satisfactory medicinal effects in clinical practice, Paozhi is proceeded according to the nature of the Chinese herbs themselves, the need of differentiation of symptoms and signs, and the different needs of depending on preparing. How to screen the active component and control the quality becomes the challenges for the research of TCM based on the pharmacological activities or the efficiency. Now there are many purposes of Paozhi. Some animal resin or other special medicinal materials with odor, like the raw turtle shell, the Paozhi could correct the odor. Another purpose is for the efficient preservation. For this, is by the termination of seed germination. TCM containing glucosides by killing enzyme and glucoside. Another one is improve the therapeutical effect. As we know, TCM herbal processing method, namely as Paozhi, might exert much influence on the conversion or transmission of plant contents and especially secondary plant metabolites. The last one is relieve the toxicity. As we know, the traditional Chinese medicine foods has great toxicity. By Paozhi, the toxicity could be relieved. Thus, it is an important subject to characterize the change and regularity of TCM during the processing in the study of processing mechanism. The TCM processing is a technique based on TCM pharmacy series. There are many traditional processing methods, including stir-frying, steaming, boiling, and so on, in order to meet the therapeutical requirements to ensure safety, enhance effectiveness, and produce satisfactory medicinal effects in clinical use. Study on the processing mechanism is a key to the science of processing. At present, modern analytical methods are mainly used to discuss the processing principle. But what is the mechanism? We raised a hypothesis. The processing of TCM might mainly enhance or reduce absorption of effective ingredients in vivo for the purpose of enhancing efficiency and reducing toxicity. Now there are many methods for the TCM processing mechanism, including chemical approach, molecular biology, pharmacology and toxicity and pharmacokinetics. With the development of modern analytical tools like LC-MS and GC-MS, more and more attention have been paid on the pharmacokinetics. Now all studies take RPM, for example, to study the TCM processing mechanism by pharmacokinetics and mathematics techniques clarifying the influence of processing on the change and regularity of TCM in vivo, and providing the scientific basis for the hypothesis. Now I would like to give a brief introduction of Radix polygoni multiflori. It is originated from the plant multiflorium sap. There are three kinds of chemical compounds. Now its functions for RPM is decortication, stopping malaria and treating boils. For the processed RPM is tonifying liver and kidney, nourishing blood and stressing tendons and bones. Applications for RPM is mainly used to treat the constipation, and processed RPM mainly used for the treatment of hyperlipidemia in clinic. Now my experiment main about three parts. The first one is the establishment of the analytical method of RPM in rice. Now the second one is the study on the effect of processing on pharmacokinetics of main components of RPM in rice. Now the third one is the study of pharmacokinetics of different doses of administration of processed RPM in rice. Now the first part, the establishment of the analytical method of RPM in rice. This is the chemical structures of 5 major constituents and 3 internal standards. First, I want to introduce the plasma samples preparation. Now the plasma samples added in internal standards, and after that the formic acid was added, and the mixture was vortex mixed for 1 minute. Then the ethanol acetate was added in it, and then they were vortex mixed for 1 minute and centrifuged for 10 minutes at 40,000 RPM. Supernatant was transferred into another centrifuge tube and condensed to gas. The dried residue was reconstituted in 100 microliter methanol and injected into the LC-MS system for analysis. Now is the method validation. The method validation, the method was validated in terms of specificity, linearity LOQs, recovery matrix effect, protection, and stability. According to the USA FDA bioanalytical method validation guidelines, the data indicated that 5 analytes were all stable in plasma. And from the linearity, the R was less than 0.99, and the LOQs in the range of 0.042 to 4.2 nanogram per milliliter. The RSDs of interday and intraday precision are less than 15%, and the accuracy is more than 90%. Now this is the specificity. The first group is the blank, and the next was blank and control, and the last one was the sample. There was no interfering peak in their peak region. Now this is the recovery and the matrix effect. There are three concentrations of low, medium, and high plasma samples, and the results indicate that they are accordance with the analysis of biological samples methodological requirements. Then, from the results, we can conclude that the LC-ESI-MS method was established to simultaneously determination of the three kinds of compounds in rice plasma. Method validation was accordance with the analysis of biological samples requirements and provides a new technique for evaluating the effect of processing on the pharmacokinetics of RPM in vivo. The stable, reliable, sensitive, and specific LC-MS method is suitable for the determination of low concentration compounds. Now, the next part is the study of the effect of processing on pharmacokinetics of main components of RPM in rice. The animals we use is SD male rice. The dose regimen was divided into two groups. One is the RPM, and another one is the processed RPM. One group for the RPM, one group blood was collected at the interval of this point after administration. Another at a different time interval. The processed RPM was the same to RPM. This is the mean plasma concentration versus time curves. The three compounds were observed rapidly and reached the maximum blood concentration at about 0.7 hour, 0.4 hour, and half an hour after oral administration of two preparation of RPM. There are two absorption peaks of emodin. The Tmax value was about 0.2 and 4 hours respectively. This is the data processing using DAS1 software to determine the compartmental model of the compounds and calculate the pharmacokinetic parameters according to the efficacy information criterion. Now the red part is the result and some parameters introduction. Now this is the parameters calculated by the DAS software. The data marked with the right was with significant or very significant difference between the two groups. The Cmax AUC 0 to 24 and the AUC 0 to the limit value of gallic acid of processed RPM extract were 4 and 2-fold greater than that of RPM extract. The difference of three parameters, MRT, AUC 0 to the limit, and AUC 0 to 24 of polydatin and PMSG were considered to be significant. Meanwhile, the Cmax AUC 0 to 24 and AUC 0 to the limit value of PMSG in the processed RPM were 45%, 55%, and 43 less than that of RPM. For the emodin, Cmax and AUC 0 to 24 was significant between them. Now this one is the histogram of some selected pharmacokinetics parameters, which was consistent with the table result. As a result, the contents of gallic, polydatin, and emodin in RPM were higher than that of processed RPM, and the PMSG was opposite. However, the absorption in vivo was different. Gallic acid was enhanced, and the three others was the opposite. So we could conclude that processing changes the contents of active component, and the doses cause the absorption changes of active ingredients. Now is the third part. Is the study on the pharmacokinetics of different doses of the administration of processed RPM in rats. The animals used was the same as before, and this is administrated of processed RPM extract with three doses. That is low dose, medium dose, and high dose. This is the blood collection times and the preparations. Now this is the mean plasma concentration versus time curves. Gallic acid and polydatin was not detected after oral administration of low dose of processed RPM owing to the low concentration. They were absorbed rapidly and reached a maximum blood concentration at 0.7 hour and 0.4 hour, which was consistent with the previous results. Now this is the influence of pharmacokinetics of parameters. Now this is the relationship. Between the pharmacokinetics parameters and the dose. There was no direct linear relationship between the pharmacokinetics parameters and the dose for gallic acid. The increase of dose promotes the absorption of gallic acid. In vivo, there might be multiple relationships between blood concentration of rice and the dose of polydatin. There might be linear relationship between the values of Cmax AUC 0 to 24 hour and the AUC 0 to limit of the dose of PMSG. We could improve the concentration in rice by enhancing the dose of PMSG. For emodin, as the dose increased, the blood concentration increased, but emodin has a purgative effect. The dose could not be enriched without limit. Now the hypothesis, the processing of TCM might mainly enhance or reduce the absorption of effective ingredients in vivo by changing the contents for the purpose of enhancing efficiency and reducing toxicity were proved for the previous studies. Now this is the conclusion. There are three parts. The first one is the LC-ESI-MS method was established to the determination of the three kind of compounds in red plasma. The third one, the next one is the processing could change the contents and the pharmacokinetics of effective components in rise of RPM and processed RPM. The last one is absorption, and those are positive correlated, demonstrated that the hypothesis was correct. That's all. Thank you.